Cool. All right. So I've prepared a few slides. So I'm going to start. I'm giving you some context of what I think is the state of the art of blockchain performance and how we can go from there. And obviously, I'll talk about Linera. So I'm the founder. So a few words about me. I'm a founder at Linera. I was previously a software engineer at Facebook and a blockchain engineer and researchers in the blockchain project of Facebook. So I was actually one of the early engineers there. And then I transitioned to a more research role. And in fact, Linera comes from some of the research. I was inspired by some of the research I was doing there that also inspired some aspects of SUI. If you're familiar with SUI objects, there are some common points here on the technical level, which are really interesting. And I can, of course, answer about that later. Okay, so I'm here to, I guess I'm here to convince you that there's still work to do on blockchain performance. So, and of course, we've seen a lot of in the history of blockchain when we're starting with proof of work with Bitcoin, there's been a lot of performance innovation, starting with going from proof of work to proof of stake with Ethereum, and I'm sure you're familiar with a lot of the innovations that have been popularized by the different infrastructure projects, such as blockchain sharding, the subnets, parachains, app chains. And then also, of course, L2 rollups. The narrative was very strong, I would say, until this year, maybe. Although we still see a lot of efforts with shard concerns to solve some of the problems related to shard liquidity in particular. What I'm interested in, what I've been following perhaps more closely, and I'm very enthusiastic about, are the modern layer ones using parallel execution and some of the shiny new consensus protocols. And so typically I would put in that category Aptos and Sui. And maybe Monad or some others, but we're starting to see really good TPS, transactions per second, like over, at least claimed over 100,000 per second. And interestingly, also the block finality time, so the time it takes to get confirmation that a transaction made it to the infrastructure, is starting to be around a second, which is pretty impressive. If you compare, obviously, if you compare to Bitcoin or Ethereum, where it's actually much longer than that. And even Solana, although they claim that it's under a second, it's actually more like around 12 seconds. So knowing that, one may ask, okay, are we done? Do we have enough TPS? Is the blockchain fast enough for everything? And so I'm going to try to explain that that's not the case in our view. And as a starting point, what we can look at is actually just how Web 2 works. Okay, so traditional Web 2, you have most applications, they can maintain connections with the server and receive notifications that will allow them to refresh their UI, their user interfaces in real time. And that's really the way users are used to use the internet nowadays. You are connected to I don't know, a messenger app, or you will input some message, you starting interacting with the system, and you expect the other users to see the result of your actions very quickly. And you expect that to be true even if there are lots of users in the system. So if you are in a traffic jam, you're using Google Maps, and many other users are using Google Maps around you, and yet everything works seamlessly as intended. So there's a notion of quality of service that is maintained during peak hours. And then under the hood, we know that it was a long process for the web to be like this. It really necessitated lots of advances, in particular the notion of cloud infrastructure and elastic infrastructures, and the fact that also you have very good latency nowadays is more often than not relies on something called geographic sharding, which means that essentially big players in the web are able to put data centers near you. And when so your Facebook account is more likely to be, if you live in the US, your Facebook account is more likely to be hosted by servers that are in the US and not somewhere else. And that's how Facebook can minimize the latency and maintain good performance. And now all of that is basically not supported by blockchain infrastructure, or at least not natively. In fact, what we can see is that the modern layer ones, so you have a layer one on the right, then there's what's going to happen is that for the user to access the layer one, there's a number of steps. And in particular, there's an API provider in the middle, because users cannot run a full node of Ethereum. It's not possible. So they have to trust, their browser has to connect to an API provider to interact with the layer one. And that's causing a number of issues and kind of contradicting the experience that users are used to. In particular, so what we have is that the layer one, with a single chain of block, you can be fast. You can have 100,000 transactions per second, maybe, but it's not elastic. So there's a limit. If you reach this limit, then the performance are going to be degraded. Maybe the fees are going to be higher. The delays are going to increase. And so from a theoretical level, the workflows of the users are not insulated from each other. If I'm relying on the blockchain for a particular task, but there's an airdrop at the same time, suddenly I could be impacted. And that's really different from Web 2, cloud infrastructure. I mean, if you run a service on Amazon, if other services on Amazon are using a lot of resources, you usually don't see that. Amazon will have done the work to provision some more machines, to insulate you from sort of a capacity crunch caused by other users. And so the systems are fast but unelastic. And then on a technical level, the fact that we have API providers is degrading the latency of the system, and it's preventing also the users from authenticating the data. So on the security level, there's a promise that is kind of broken currently by layer ones, which is that the users have to trust an entity that is not staked for the integrity of the data that you're displaying. That's something that we accommodate with, but it was not really the philosophy initially, and also that could be a problem as we increase the level of automation in the world of blockchain. That's something that could become a problem. So what we're proposing at Linera is that we'd like to solve this problem. We'd like to have an infrastructure that can provide secure real-time applications and make that easy. So some of the applications that would immediately benefit from that kind of infrastructure, so payment systems. We want to have sub-second latency. And by that, I mean that if I click on my UI to send you some money over this infrastructure, then you will see in your UI the money arriving in your account, and you will know it's secure and it's really there in less than a second. And that's something that is hard to do, and it's not included in the notion of the usual notion of finality time. Doesn't include the time it takes for other users to see your transaction. So that's really something to keep in mind when reasoning about latency, and that's something we really want to solve. So obviously, gaming, on-chain games would really needs this kind of on-chain interactions, so if I play a game of chess and I make a move, I'd like the other user to see the result of that move very quickly. If it takes 5 to 10 seconds, as it is the case right now with layer ones, then it's not a very fun game to play. And that's basically one of the reasons on-chain games are not so popular these days, or at least didn't go viral in my view. Other applications, so of course you can use games for, you don't have to have the entire game on chain. You could use just rewards, and if the rewards are faster, potentially that's something that the users would appreciate, making the application more fun. And then when it comes to real-time on-chain interactions, what I think is going to be a game changer for is what I like to call multi-chain DeFi. So if you have a user intent, so if you want to make advertise that you want to buy an NFT on Solana, you could create with what we are building. With Linera, you could create an auction and have the system manage this auction at a very low latency, let the solvers come in, and you have like the fact that the auction is able to send notifications to the other solvers, and the solvers can trust the result, will be instrumental in really improving the efficiency, the financial efficiency of the system. Yeah, so how are we going to solve this? So we at Linera, we are inventing a new concept called microchains. So we want to, as long as we use a single chain with large blocks, I was explaining a bit earlier, we're going to have latency problems, and it's going to be hard for clients to authenticate the data that they read from a blockchain. What we're proposing is a system that is different and not really meant to replace existing layer ones. What we're proposing is a system where you have a large number of chains that are running in parallel, and each of those chains is small, so that we call them a microchain. We'll see that that's a good way to solve the latency problem and really provide a complementary solution that's going to work hand in hand with existing layer ones. And so if you're familiar with the notion of micro rollups, essentially we're proposing to go even farther and provide a microchain for very fine-grained tasks, such as just one game of chess or holding the assets of one user. And that's how we're going to build a system that is truly elastic and with actual guarantees of performance, disregarding the number of active users. Okay, so now I have a few technical slides. How do microchains work? So we want definitely liquidity to be shared across all the chains. So we have only one set of validators. All the chains have the same level of security. One of the innovation of the Linera protocol is that in the microchain is that the block production, so producing blocks, is separate from validation, and we can configure each of the microchain in a specific way so that the block producer of one chain could be one user or could be just a few users. If the chain, for instance, is meant to be a game of chess, we'll have only 2 users able to produce blocks and using that chain. So now you have to imagine the difference between playing a game of chess on chain when you're using Aptos or Sui or Solana. So all your moves are going to be in the middle of very large blocks, as opposed to in Linera with the microchain, you have only one dedicated chain of blocks with tiny blocks and maybe 1 transactions per block. So of course the system can now optimize for super low latency for these 2 particular players that are using this chain. Okay, and so Linera is the first infrastructure based on microchains. It's secure by proof of stake and really aims at leveraging this technology to provide the lowest finality and real time, like a Web2 feel to the on-chain applications. Our applications, we are using the Rust language on top of the WASM VM, which makes us closer to Solana. So that's why I was very interested in Solana Breakpoint. We already thinking about talking to them and trying to see if we could have a native bridge with Solana so that we have this possibility to quickly spin a microchain from a Solana transaction and spin, for instance, a game of chess or micro auctions. That's something we have in mind that we're very excited about. So yeah, another diagram. That's just to explain that how we solve the problem of security also in Linera is our wallet has very interesting features. It has a VM, it can replay transactions, it can act as a data provider for the web UI. So we are already reinventing, if you remember the diagram I was showing you earlier, we're just completely reinventing the way a client can interact with a blockchain with a layer 1 securely. I made the list. So for a number of applications, we can provide immediate benefits, and we already have a number of partners that are aligned. In particular, a company specialized in zero-knowledge proof. They want to use Linera to manage, to create a proof verifier network. They are very interested in our programming model that allows managing a proof with a single user, something that they were basically rediscovering on their own, and they were about to program from scratch, and then they heard about us. So we're super excited about this. Yeah, in general, we're having really good discussions with a number of companies, a DeFi company that is interested in also the scalability and the guaranteed performance of Linera. So very interesting time for us. Yeah, so what we're proposing in summary is a new programming model based on many parallel chains instead of a single chain of blocks. It's a programming model that doesn't necessarily aims to replace existing layer ones, but work in harmony with existing layer ones through low latency bridges. And it's the only programming model that can that allows elasticity and geographic sharding. So we know that no matter what, we will be able to be the lowest latency out there for on-chain applications, because we are the only ones that could put a data center ask our validators to put a data center in every region in the world, so that our users are guaranteed that they always talk to one particular endpoint in their region when they interact with Linera. And that's it. I'm happy to take questions, and thanks for the invitation again.
Okay, well, thanks a lot, Matthew. That was super interesting. Can we start with your time at Facebook? When you were doing research, what problems were you researching? What were you trying to solve?
So I started with the design of the Libra BFT protocol. So basically, the problem we are solving is we need a consensus protocol in Libra. So there were a number of research papers, but they were not in sufficient detail, not explaining the protocol in sufficient details for the engineers. So I worked on the specifications, the first two versions, and then I handed over the project to my colleagues. And then I started working on academic research. So the project I was mentioning that has a kind of a common ancestry, is a common ancestor to Sui and Linera, is called FastPay, and it was a infinitely scalable payment system.
And so that got shelved at Facebook, and now Stewie is deploying that.
So when we were working on FastPay, it was an academic project. We had a nice paper, some code for benchmarking purposes. It was not used at Facebook back then. They had other problems to deal with. My colleagues, when some of my co-authors, they became co-founders of Sui, and they took some of the ideas to create the Sui objects. So Sui is a very interesting project. It's a hybrid model that has a layer of infinite scalability and also a normal high TPS chain. It was very interesting to see how they use some of the ideas of FastPay in there. At Linera, we specialize in the horizontal scalability, so we have only microchains, and that's what makes us also kind of a good fit to work with other layer ones, because we're not trying to replace them. We didn't code a high TPS chain inside Linera. We prefer to work with an existing one.
As you described it, it sounds, in my limited technical ability, most like Cosmos.
So the difference between Cosmos and Linera is, and many systems out there, to be frank, they considered blockchain sharding, and so what they wanted is to have many copies of a traditional blockchain, and each copy would have a dedicated set of validators. And so the difference, and that the benefit of doing that is that the validators would stay small. However, it creates a lot of complications. And the security model has to be has to be weakened. It's not completely clear when you have lots of different blockchains with separate set of validators. You need to work more to make them communicate. Communication has to go over the internet, and then there's also there's a problem of why would a chain trust another since they have separate validators, so they are kind of sovereign, and so that's a problem we avoid that completely in Linera, because we have only one set of validators, shared liquidity, shared security. However, our validators are elastic, so they need to be data centers. And down the road, we want them even to have several data centers, one per region.
Okay. And I'll open it up to questions from the audience. So raise your hand if any of the other committee members have questions. I'll ask my last question, and I have others if other people don't. But how could the collective be helpful in our 30 experts on the call here be helpful to Linera?
Oh, well, I'm super interested in hearing your feedback to begin with, and then after that, yeah, we'll see.
Okay, happy to give that. So does anybody have in the audience, any of the members have? Okay, first question is from Kelly.
Hey, Matthew, great presentation. So, from my understanding, you also mentioned you are not trying to be the layer one, but you can actually live on other layer ones. Is that correct?
So our programming model is different. We're not trying to replace layer ones, but we can certainly be a sort of real-time coprocessor, if you like that term, and have native bridges with a number of layer ones, so that they can spin microchains on demand and benefit from the real-time interactions for a particular moment. For a particular task. We also don't mind if people use Linera as a layer one and have liquidity blocked in Linera. They can totally manage assets in Linera, and then they will be able to have their own chain that is permanent.
Right. So if I understand correctly, let's say if you work with Ethereum, would you just be an L2 but still settle on Ethereum, or right?
So yeah, so we have a roadmap to become an L2 of Ethereum, if possible. It's a possibility technically. It is a lot of work. Since we are already decentralized, there's the question whether having the L2, the confirmation on Ethereum, is something that would really benefit our users. But it's possible. Yeah, we have a roadmap for that. And in fact, the partner that we're working with, that is a ZK company, is going to do that. They want to build a ZK rollup using microchains.
Right. And what would you say as the use case that can only be done in your infra, but not on the others?
Yeah. So I had a slide. So in general, if you want real-time on-chain interaction, so if you want users to interact with an auction or a game, and the game is fully on-chain, we are the only ones that can provide this end-to-end latency, user-to-user latency, that is like going to be like below a second. So the time I create a block and the other user is notified and then pull the data and can update their UI is going to be very low in Linera, and something that's not possible in other layer ones. And so for micro auctions, so there's an entire field of DeFi that we think we envision can be built on microchains that will look very different from traditional DeFi.
Okay, thank you.
All right, we got the next question from Tim.
Thanks, Lou, and thanks, Mathieu. Appreciate the presentation. Just to follow up on Kelly's question there, can you take one of your use cases and then help us understand what it is that's happening under the hood for that particular use case, that transaction, versus, let's say, on Solana or Ethereum or something that we're familiar with, so we can understand the contrast and the mechanics a bit better?
Yeah. So, and maybe I can start with...
Hey, Matthew, you
yeah.
can... Oh, if you want to go to one of the slides, but other than that, when you're talking, you can get rid of the slides if you don't need them.
Oh, okay, yeah. Yeah, maybe just for this one. So so if you are running an on-chain game in Solana, so as a user, so you'll have to So your wallet is going to sign the transaction, and the transaction is you're gonna interact with an API provider that's going to push your transactions to a mempool, or at least in traditional blockchains. I guess there's no mempool in Solana, but there must be something equivalent. The transaction is going to be eventually picked by a validator to make a block, and then that block is going to be finalized a certain number of seconds later. So in Aptos Suite, that's going 1 second later. In Solana, I believe it's more like 12 seconds later. Then the block needs to be picked by a full node of an API provider and indexed. And then that API provider will need to know that there's another player somewhere that wanted to be notified when the block was happening, when this chess move was happening. So you need to modify that user. And so you can see that in this process has already taken probably like in the 10, 15 seconds. And so if you're going to play on a chess game, it means you have one move every 30 seconds, I guess. So that's not a very fun game. So in the difference is that in Linera, you have to imagine on the left, one of those microchain is dedicated to this chess game, and the blocks are tiny. They contain only one move. And now, as a user, there's a dedicated protocol that allow me by talking directly to the validators. So my wallet is talking directly to the validators. I'm proposing a block and getting it confirmed very quickly just by pushing my block and doing a few round trips. That block then is going to extend the microchain of the chess game. And then the system actually knows that there's another player that is interested, that was tracking this chain, and is going to notify it through the open connections from their wallet. And they're going to be able to quickly pull the new block and refresh their UI. Actually, this diagram was better, I realize now. And so you get, not only you get the super low latency, but you also get the data end-to-end security, because the chess game would be replicated securely in all the players of that game. It's kind of in the dream of the early founders of blockchains would be that everybody would have a full node, and then this dream was kind of given up because it's just not possible to have a full node of most of the layer ones out there. With Linera, we're bringing back the dream and putting a full node inside the user wallet, except it's a full node for a tiny microchain or a few tiny microchains. And only the validators have to have a replica of all the microchains out there.
Thank you for that. And just two hopefully quick questions to follow up. Now, you talked about security. Is privacy a feature of Linera? And then also, what about the payloads that these blocks can hold on these microchains? What is it good for? What is it not ideal for?
Right. So privacy is not natively supported in Linera, but we are privacy ready. And by that I mean that because our system is very elastic and the workflow of the users are isolated in different microchains, if I push a block that has very complex computation to support privacy, then the system is totally fine with that. And the other users, if they don't use privacy, they don't pay for it. And if I use privacy, I pay for it, and the system is just working as a nominally. And in fact, some of our recent partners is going to manage ZK proofs inside the microchains, and definitely tapping into this possibility to make heavy computation inside microchain.
Thank you. And then the payload, the block payload, what's its capacity?
So our architecture is optimizing for small blocks. We prefer small blocks, but we have the possibility to upload blobs to the system and then refer to those blobs, so immutable pieces of data, to refer to them from the blocks and share them between microchains. So yeah, so that's how we see the programming of the system. If you wanted to have so each microchain right now is optimized to be relatively low TPS. We're not trying to have 100,000 transactions per second on one microchain. It's more like 1-2 blocks per second. And what makes the TPS is just the number of microchains total. That is virtually unlimited. A microchain is a little bit like a user account for us. And if you don't use it, it sleeps in storage, by the way. That's a very important characteristic of the system.
Thanks, Mathieu. Appreciate it.
Yeah.
Okay, thanks, Tim. Next question is from Kyle, and then I think the last question will go to Taco. But Kyle?
Cool. Yeah, I'll try to keep but I really liked what you were just saying to one of Tim's questions about how you know, people like OG people would really like this. And you know, it falls back to a conversation I had with the CTO of Scale Network. His name's Stan Kladko. He's like a gigabrain. He helped build the Java virtual machine, which is crazy. But
Scale is an
SKALE, yeah. Scale Network. And anyways, one of the things he told me is that his vision is that basically everybody has their own personal Solana. And it's kind of like, I see that this is kind of what you're almost like trying to build, like thinking that like, you know, your corner store bodega or like your corner store will be running its transactions on a blockchain that's like proprietary to that specific place. So I'm just curious, like where your vision of like where you can take this type of blockchain technology.
Right. So we're working with the Deepin company, and so down the line there could be a microchain in every car that they manage, in every charging station. And so the value proposition here is that the charging station or the car, I mean, let's say the device, in their own microchain, they know that they can always post a new update with constant latency. The system can give them like an SLA. Like every time I want to post an update there, I will be able to create my small block with this update and get it notarized in the system, no matter what happens in the rest of the other microchains. And then of course, I mean, didn't mention, but there's a native cross-chain messaging system. So with my microchain, I can also receive messages from other devices and maybe the coordination layer of my Deepin network. And then I would be able to react to them by executing the code, the on-chain code. So benefiting from transparent computation and decentralization at a very low level in the stack.
Okay. The last question is from Taco. The question was answered.
GM.
Microchains.
So I just had some questions and stuff like that, sort of looking through everything that you have. Who's building on you right now? Are you still at theoretical stage of like documents and tech improvements, or how quickly are you looking at getting into you know, the mainstream of usability, and what's on the horizon of coming up?
Okay, yeah, thanks for that. So we have a DevNet, and we are going to announce a testnet very soon. So that's our stage, and we want to be mainnet next year at some point. In between, we'll go through a Series A, and we'll have to obviously increase the size of the team. Right now, we are very lean. We are around 12 people, which is the right size for our seed stage, and you know, like explaining, like developing the tech, building the protocol, and getting the first early adopters. But yeah, to go to market, we want to do a Series A and start pushing way more the marketing, developer adoption, and doing the whole thing with grants.
So are you gonna be participating in like hackathons for people to build on you?
Yeah, we have done a few online hackathons, so we got some good results. There's already so a few games. There's a person that is very interested in a social network built on top of Linera also. And then I think the most interesting partner that wants to build on top of Linera is the company that I was mentioning, doing a proof verify network, because they're actually they are the same size as us basically, and they are going to invest heavily in the tech of Linera to build their new product.
Awesome. Thank you.
Yeah,
And
thanks.
I saw that Danny grabbed your dropped your email, so I'll shoot you an email as well. I'm Taco from Manifest / 0xDgens. So yeah.
Right. Me too.
Yeah, so Matthew, thank you so much. This was really super interesting. Any any last thoughts that you want to leave us with before we sign off?
No, thank you so much for the invitation. I really appreciate all the thoughtful questions, and hope to be able to stay in touch with some of you.
Thanks, Matthew.
Okay,
It was really
terrific.
great.
Yeah, that really was terrific. Thanks, Matthew. Have
Have a good one.
a great
All right.
Wednesday, everyone.
See you.